Hi everyone, it is me, Elliot Jacobson, and I'm just getting this thing going. So the first thing I need to do is hear from chat that we can hear me and see me and that everything is working appropriately. So let me just double check that that's going on. So if somebody could please from chat just say, hey, we hear you, you are coming through, and then I will go from there. So hi everyone. I'm looking at chat over here. I should put chat somewhere not quite as off the screen so I can see it. So yeah, just say hi Elliot, I can hear you. And all right, thank you everybody for saying you can hear me, and hi everyone, welcome to a rather spontaneous edition of Ask Me Anything, where, I don't know, ask me anything. There are a couple rules I hope that you will not mind too much. One is that please don't spam the chat. I don't have any sort of timer or moderators around. So if I do see you just sort of posting a bunch of messages and filling up the chat, I may give you a timeout. And likewise, any trolls, obvious things, I'm just going to immediately remove those folks. The other thing is, and I got to this point in the previous live I did just a month ago, was that there are certain individuals out there that I just don't want to talk about. And if they're brought up, any questions are asked about them, I will not answer them. And some of you know who I'm talking about. So don't be surprised if I just ignore your question, even though you might think it's just a good one. So please, I saw there was some pre-chat, and so I am going to start with anything you want to ask right now. So if you have a question, now is the time to post it. I'm going to just sort of start with now. And so anything previously posted, you missed out. I'm sorry, you have to ask again. So in order to give you time to ask something, I just sort of want to take you back in time to, I guess, what was a week ago today, actually exactly a week ago today, when I put up this little tweet right here. And let me just say that I thought this was a throwaway tweet. I did not really think that this one was any more or less than any other. In fact, if you look through my timeline, you will see that on the very previous day, I had put up another tweet about exactly the same chart with, not quite as much of a vertical spike yet. And so I was just like, oh, it's another day, another record for the North Atlantic. Nobody's paying attention. And as some of you may know, this one went viral. By the next morning, it had 1.2 million views, and now it is currently at about 2.9 million views here. But as some of you know, it's kind of gone viral around the world, probably better part of 100 million views over the last week. So that's something unexpected. So I've been sort of having that occupy a lot of my attention over the last week, and I am grateful to the world media for picking this thing up. I mean, what does it take for the world media to pay attention? Apparently I use the right colors and fonts. I don't know. I mean, there is stuff a lot crazier than this going on right now. I mean, this is kind of crazy, but there is stuff that is a whole heck of a lot crazier. And I may have opportunity to show you some of that today if those questions are asked, or I just have some extra time. But at any rate, so this is what I'm hoping, topics related to all of these sort of records, not only just the temperature of the North Atlantic, but global ocean temperatures, global surface temperatures, Antarctic sea ice extent, and anything else that is on your mind. So let us just go from that, and let me fade back here so that you can see my whole face. So let's see. I have a question. From Kelly Green, what do you make of Tonga injection of water vapor as contribution to recent rapid warming? Do you have specific data on water vapor? I do not have specific data on water vapor, but let me say that this was a massive stratospheric injection of water vapor. There's no question this is going to lead to some warming, and some climate scientists are saying that this alone could get us to 1.5 next year. And this water vapor is greenhouse gas on steroids, right? So we have this volcano underwater injecting all the stratospheric water vapor. But you see, that water vapor has been around now. I believe the eruption was January 14th, 2022. It's been around more than a year, this water vapor. So it certainly couldn't be a direct cause of such rapid heating. But what is probably it's one of the things that has led to rapid overall ocean heating, right? So surface heating is different from overall ocean, all the water, the total heat content of the ocean, if you don't mind. And so that heating has really accelerated in the last 3 years. Unlike global temperatures, every single year, the ocean has more total heat content, and it's a record for the modern era, and that's year after year after year. So, the heat content is going up. Tonga certainly is helping that, and so now we have some other things happening that sort of all conspire to let some of that heat make it to the surface. And so, it plays a part, but I don't think it's as direct as some have said. We can't save coastal cities, but we can save species. All right. Let's see. Mark asks, I haven't read this yet. Does considering the planet as a pool house rather than a greenhouse alter our view of our predicament? I have never heard of it called a pool house before. So, we're in the same predicament no matter what words we use to describe it. Some of you may not sort of know this linguistic differential between a problem and a predicament. So a problem has a solution. A predicament is a situation with no way out that doesn't involve great suffering and trauma. So we are in a predicament, we don't have a problem, and so just really simply, I don't know what pool house means. I will look up the word, but maybe it'll help me explain things better. I don't know. Guitar 47, environmental coffee house on ocean heat was interesting. What was your take and synopsis? So a oceanographer named Jim Massa, M-A-S-S-A, was featured recently on Sandy's show. And I was really happy that he was on there. I was exhausted, so didn't listen to a lot of it. But what you just heard me say about total heat content of the oceans, I actually know that because I watched that show. So I hope that you will catch that episode, but I don't have anything in particular to say. Guitar 47. Hold it. Bernard Mark says PBS NewsHour talked about it. I know, wasn't that awesome? I know. They started by showing, the sort of a fade image of my Twitter account and then brought up, this slide again. So this is sort of what they did. But what was interesting was that the newscaster herself did not describe this chart accurately. So I don't remember her exact words, but rather than saying, this was a temperature anomaly, it was something like, these are the temperatures, or, she wasn't recognizing this for what it was as an anomaly chart. But that said, one of the things that has been really surprising to me as this has developed is that I mean, I'm just a guy who did this. Honestly, I do this in my garage, right? I am the proverbial, guy in his garage doing his own analysis. So what surprised me is just how flat-footed the international climate community was, all these climate experts, in their immediate response to this tweet going viral. And what I was grateful for was that none of them said, "Oh, Elias got it wrong. He didn't plot the data right. He doesn't understand." Nobody said that, right? Nobody was like, "Oh, we have to correct Elliot. He's not a climate scientist." And the PBS NewsHour in particular, they said, "Should this be worrying?" And the first response from their guest in that particular episode was, "Yes, absolutely. This is worrying." And I deeply appreciated that we have people on, our media who are able to say that to a camera now, right? Who have that voice. We're not talking about this sort of being swept under the rug. The difference this time is that people said that, yes, this is worrying. And you're hearing that over and over again in the media. These are extreme events. And, I'm grateful. All right, let's see. Where are we here? I just sort of went through a lot here. Carl Hans, any words of advice for people finishing college or coming out of school, as in what to do with the rest of your life? Wow. I don't. I think everybody has to make their own decision given the information they have, but it also has a lot to do with where you in particular live on this planet. If you are in certain parts of the planet, it might be a great idea to start thinking about relocating now that you're out of school, finding a job in a place that'll probably, be around a little longer. I think that migration is part of your future. I think that's something to think about right now. You just got out of school, make a choice that will be a good choice for where you're going to end up. You don't, in this country, you don't want to end up in Florida or Texas or along the Gulf Coast or parts of the East Coast or in California, Southern California or Arizona. I mean, there's lots of places you don't want to end up on this planet. So that's the best advice. I mean, the other advice is, if you could dedicate your life to something that benefits the planet in any way. We're not talking about saving humanity here, but we are talking about saving the planet for whatever comes after humanity. Anything you can, any life choices you can make like that. I wish I had a kinder word for you at this point. Let's see. Bernard Marks asked the question, we already passed 1.5 C this year, did we not? No. I mean, yes. No, yes. So we passed 1.5 on a daily basis. There was a period about a little more than a week ago now. And this one went semi-viral just before the one went viral. So the first week of June, where global temperatures 60 north to 60 south did average over 1.5 C over the 1850 to 1900 IPCC baseline. And you can actually Google that and find articles saying that. And I actually published that. And some very big names out there kind of stepped in it a little bit because they thought, oh my God, we breached 1.5 C way earlier than anybody thought. No, we have not breached 1.5 C in the way that the IPCC means it. And there's 3 different levels of this. And this is why this question is so good and why this is so confusing for people. The first level is, did the planet break 1.5 C for the day? Yes. In fact, you can trace breaking 1.5 or even 1.7 C back to 2016, right? This has happened before. It will happen again. That's not the same, right? The next level is having an entire year over 1.5 C. And that is now becoming increasingly likely next year. And that, people will say, oh, it's been 1.5 C for a year, so we've broken 1.5. No, that is not what it means. The actual way this is phrased is that the long-term average has broken 1.5 C. And right now, the long-term average is going up by about 0.2 C per decade. So if we are a little bit over 1.2, let's call it 1.3, right? If we're 1.3 now, which we aren't, but if we were 1.3, then we have a full decade before we could really say, now we're at 1.5. I mean, realistically, 1.5 for the long term. I mean, things can happen, right? But, 2035 is a reasonable, but maybe more like, maybe a little bit earlier than that. So yes, expect a year over 1.5, probably next year or the year after. Expect a couple of years in a row as we go on, and then La Nina hits and it drops back again. All right, but to be solid, 1.5 or higher, probably early mid 2030s. Great question. Great question. Let's see what else. Let's see. Martine Wienman. I am living in the Netherlands, a country of which half the area is below sea level. Yes, I'm a PhD candidate working on climate adaptation in Netherlands. We don't include this angle. Do you consider that naive? I'm not exactly sure what angle you are referring to. Netherlands is a bike-friendly country that is used to essentially dealing with water, right? So Netherlands is a model for much of the planet on how you deal with rising seas and transition to a non-fossil fuel economy. So I'm not exactly sure what angle you're referring to, but one thing about the Netherlands, just so you know, this fabulous climate scientist, Leon Simons, Simons, is from the Netherlands. And he is the one who sort of encouraged me to do a couple of these charts a couple months back. And he has also sort of guided me by the hand to where I could get certain data for databases. I am very fond of everything going on in the Netherlands as far as your awareness of climate. Just wanted to add that. All right, let's see. So Elliot, the 2 meter on the ocean temperatures means measures are taken at 2 meters. So I think you might be confusing things, Diego. There are two different measurements that go on here. One is the global 2 meter surface temperature. And the idea there is that we want to avoid ground effects, right? So get your thermometers away from the ground so you don't get this artificial radiative heating. You know how they say you can fry an egg on the ground, right? Well, we don't want that to be the measured heat when we're trying to measure the global temperature. We don't want, the ground impact. So you want to be, 2 meters off the ground to avoid that. And that's sort of the global number we try and use. And, there's a little bit of fudging there site to site. But that's roughly what we're talking about for 2 meter temperatures. Global sea surface temperatures, we're actually talking about the temperature at the surface or in the first few, and this varies. If you look for definitions for sea surface temperature online, you'll see that there's sort of a range of depths. But because these sort of measurements take place both by satellite and by buoy and by ships actually, passing through the night, there is just a range of ways these are taken, but because it's sort of been consistent over time, we can talk about the sea surface temperature and have sort of consistent satellite data and buoy data and shipping data so that any noise in that data by one thing being deeper than the other at some location is sort of filtered out and we get a very accurate number globally. hopefully that clears that out for you. Bernard Marx says that I like this comment very much. Problem versus predicament is like the difference between preppers and doomers. Preppers think collapse is survivable. Doomers know it is not. I don't know that collapse isn't survivable. What isn't survivable is the sixth grade extinction, which is coming on its heels. So whether humans are or are not involved in the sixth grade extinction, I tend to not want to take a side on that. But this idea of problem versus predicament is very good. You know, preppers are the ones who have shelters and supplies and are really expecting collapse to happen and are building up stockpiles of what they will need to survive for long periods of time after this collapse happens. And, you know, I don't think there's anything wrong with that. If that's the life you want to live, go for it. But I mean, in the long run, this planet is going to become less and less habitable for humans. And if your particular bunker is a location with a lot of other humans who are hungry, you might have some issues. Or if it's in a location where there are wet bulb temperatures that are lethal, you might have an issue. You know, there's all sorts of reasons that preppers are sort of might not have the right answer they think they do. On the other hand, I think it's good to be for all of us to be a prepper a little bit. You know, I certainly have water supplies and pounds and pounds, I mean, big sacks of rice and that I keep. I mean, because things could happen where they last a week or a month or even longer, and there could be some transition period. And if the transition period is into sheer global chaos, and then I'm dead anyway. So I tend to not be one who looks towards trying to survive total collapse of industrial civilization. Kimberly Collison, let's see, says, thank you for taking questions. If humans disappeared within the next year, they won't. And we were wise enough to turn out the lights on the way out. We certainly wouldn't. How do I think climate collapse would progress? In other words, if you were to completely take out humans today, right? Something happened, you know. Well, the first thing that would happen is massive heating of the planet, right? Almost immediate massive heating. And I'm not sure how long that would last, but the reason is, of course, that our pollution, you know, we generate a lot of these sulfate aerosols, industrial and shipping and other ways that lead to the so-called global dimming or the aerosol masking effect. James Hansen called this impact, you know, humanity's Faustian bargain with fossil fuels. The idea that we need to reduce fossil fuels, right, to stop putting greenhouse gases in the atmosphere. But if we stop using fossil fuels, then we will stop generating these sulfate aerosols that provide sort of this reflective ability, you know, to send solar radiation back out into space. And so that's even going to make things worse faster. All right, so that would be the first thing that would happen, is an immediate warming. That warming is going to accelerate ice melt and sea level rise. And, you know, we have, because of all the heat that's been put into the oceans and all the CO2 that's in the atmosphere, there's going to be lingering heating for other reasons that goes on for at least the next 100 years. And so, yeah, there's going to be massive species extinctions ongoing no matter what humans do. And there are going to be some huge geological and environmental changes, you know, even if humans disappeared today. I mean, what's done is done, right? We're doing more damage daily, but what's done is done. All right, great question, and I'm not sure I have a lot of answers from that. Let's see what else is happening. Absolute vegan. Yeah, good. All right, Canadian fires are illustrating the aerosol masking effect by cooling the Northeast USA. Okay, I mean, the problem is that ash is a different type of impact. In a lot of ways, it traps heat, and because of its dark color, it doesn't reflect. But yeah, ash is well known, at least, to have a temporary cooling effect. So, if you have a day that is where the sky is covered with ash, then yes, you are going to definitely experience it being cooler than if those fires weren't happening. I'm not sure that's a great consequence, having air that is unbreathable because of ash, but consequently your temperature outside is a few degrees cooler. Let's see what's happening out here in the stratosphere. All right, I am losing track of where I am here. Let's see. Julian Brody says relocation works only on an individual basis. Yeah, I agree. Bernard Marx says, by turning out the lights, do you mean decommissioning all nuclear energy facilities? So this idea with nuclear power plants, sort of globally going meltdown, globally melting down, sort of synchronously. I take no position on that. That is an extreme thing to say. And so, yeah, clearly if humans disappeared, we'd have global meltdowns of nuclear power plants as well. So that is a world that none of us want. So let's see, what else do we have? All right, let's see. Sorry for all of this. I'm just trying to look through the quotes. A few more questions. All right, Andre asks, Elliot, do you foresee 120 Fahrenheit in the USA later this year? Yes. Yes, absolutely. I mean, look, if you look in Arizona, Laughlin, or the Death Valley, I mean, routinely gets to 120. I mean, the question is, will it get to 120 in Phoenix? I mean, 117, 118 is not unusual there. So yeah, probably. So yeah, 125 in the US, very well in Death Valley. I don't know. Those are speculative numbers, but yeah, okay. Let's see. What is the average angle of glaciers in the Arctic and Antarctic? I have no idea. Sorry. The question is, what is the water vapor parts per million? Average CO2 is about 424. I don't know anywhere that measures that, Dale. Dale Wolver asked this excellent question. Again, water vapor is this tremendous greenhouse gas. But for example, a cloud, if you see a cloud in the sky, I believe it has about 1,000 times less H2O in it, water vapor parts per million, than CO2, right? But every water molecule is looking for a dust molecule to sort of, attract, they attract each other electrostatically. And so, you end up seeing the water vapor, even though there's not a lot of it. So it is a very powerful gas. And that's why when we inject, massive amounts via the Tonga volcano, that we can have this lasting impact. That was not very eloquently said. If sulfur emission, so Valerio Frito asks, if sulfur emission related to boats and gasoline is used to cool the planet, assuming the climate engineering is possible and true, are we going to get more acid rain and more acid oceans? So, I mean, sulfur is a pollutant, right? And sulfuric acid is something that is part of the chemistry of these sulfate aerosols. So that, I'm not really sure about the atmospheric chemistry that leads to that in particular as a consequence. So I am going to just not answer that. Okay, let me put these things on hold for a second and just for the fun of it, show you something else here on my YouTube. So what I'm going to do is to actually open my Excel spreadsheet that I use to generate that chart and just kind of give you a little tour for a second. So here we go. So what I have here today is the data that actually goes through today's temperatures. And so we can see that we had this rise right up to this sort of meteoric point, which is where, I got all this international attention. And it was just by chance that was sort of coincided with this peak day. I mean, that's just how things go sometimes. So I've been following this every day, and I just want you to notice that we did go down for a couple days, 3 or 4 days, but we've hooked back up again, right? In the last 2 days, we're starting to have this anomaly increase again. And I'm going to be paying attention to this. I will certainly post it if anything important comes of that I think needs to go on to my Twitter. This is where I sort of plug in the data every day. I mean, this is just I am waking up, and the data is actually published at 8 a.m. my time, and I'm waking up and I'm putting in the numbers. And today's number was 22.89 Celsius, up from 22.81 yesterday. So that's how data goes into this thing every single day. And then I update several things, but let me just point out in this one column, so you can see some of the columns I have across the top. The average is really the 1982 to 2023 mean. I have the standard deviations and sort of the chances and the odds. And if you look down here at the bottom, I just want to make this point. The current standard deviation for the sea surface temperatures away from the mean is 3.39 sigma. So if you know anything about normal distributions, that's about 1 in 2,900. At the peak of this thing, when we had the peak anomaly, we had 3.83 sigma, which is about 1 in 15,000. So, I go through and I have page after page of calculations I'm doing and so on and so forth. And then I have these outputs for these various things that I post. And on this page, I have various things that I post. So I'm just sort of keeping track of all these things as we go along. And whenever something is interesting, I'll put it up there. So I'd like to show you the one that has to do with the global sea surface temperatures. Because that is kind of more important at the moment. And let's see, I might have to do something right here for just a second. Yeah, okay, so here we go. So here are the global sea surface temperatures. And here what I want you to notice is that standard deviation for today's temperature is 4.23 sigma, which is about 1 in 84,500. So what is going on globally with sea surface temperatures is an order of magnitude more wacky than the North Atlantic, right? So we're talking about, from 3.3 to 4.2 sigma. This is huge. This is orders of magnitude more significant. And yet that was not the story that was told. And, I wish it was the story. I wish that, that instead of the North Atlantic, that people had focused on this chart when I put it up there. you can see the red line right here. These are the daily sea surface temperature anomalies for the whole planet, right? And you see how crazy this is compared to what anything that has ever happened in the past now, right? These numbers are just bonkers, these daily sea surface temperatures, right? At 4.2 sigma. So, I wish that got more attention in the discussions, and some very smart climate scientists did raise this point. They would say, well, it's not just the North Atlantic, it's actually the whole planet. And just to give you some numbers, there is this website called Ceres. And when you look at that in particular, I'm going to just pull it up here. Hang on for a second. So Ceres. All right, so here we go. So this is a website that has to do with what is called the Earth energy imbalance. And you can actually keep track of that imbalance. That's the difference between the incoming radiation, solar radiation, and all outgoing radiation of all types, right? All possible outgoing radiation. And so if you actually keep track of this, what's going on with this difference between incoming and outgoing, and I'm going to try and do this. I'm stumbling a little bit on my words because I am trying to get these things sort of loaded in real time here. This is the chart that kind of blows me away right here. This is why the oceans are heating up. You want to know why the oceans are heating? It's this exact chart. The effect of ocean heating in Hiroshimas per second, this difference between incoming and outgoing. I make this chart by downloading this information, this data from Ceres, right? And then I ask, okay, the effective difference between incoming and outgoing, it fluctuates a lot through the year. So let's do a 36-month running mean. And why do I do that running mean? It's because that's what James Hansen did, all right? When James Hansen mentioned that the Earth energy imbalance is the single most important metric for sort of keeping track of where we are in climate change. When he said that, and then he gave a graph with 36-month running mean, I said, that's what I've got to do, only do it for the ocean. And if you've been following sort of the discussions that have been going on, the current number is 89%. 89% of incoming excess energy is being absorbed by our oceans. That's the number. So what I did was to sort of translate all this information into Hiroshima bombs. And you see we are at an all-time record rate of heating of our oceans. Nearly 10 Hiroshimas per second right now in ocean heating, given the current Earth energy imbalance. And what that means, if we track this 3-year average, 3 years, right? That is 930 million Hiroshima nuclear bombs that have gone off, and all 100% of that energy has gone into heating the oceans. So the global oceans are really where the story is. The press got caught up with this North Atlantic stuff, but it's really the global oceans that simply should be what we're paying attention to. So I just wanted to sort of take you on that detour a little bit, and hopefully that was interesting to you. And now I am going to go back to your questions and see where we are. How you doing, everybody? You okay? Everything going good here? Wow. Let's see. Poppy Davis says, nowhere to go, nowhere to hide, but I'm growing a garden anyway. I'm having trouble with my garden this year. Oh my. I have some herbs, and they've just been, because it's so cold here in off the West Coast. It's been so cold, damp, rainy, right? That the things you thought you can grow just aren't growing. My tomatoes are completely, they're moldy, right? They're just dying. No tomatoes have, I'm getting flowers, but nothing is getting pollinated. So yeah, I'm having trouble with mine. So let's see. Where are we? From which databases do I get the data which I build my charts? Are there contradictions between different data sets measuring the same thing around the globe? Okay, so I don't know if there's contradictions. I use the best data I can, so I go to NOAA data sources primarily, but I also like when we're talking about El Nino, I kind of like to see all the models, and there's actually the Australian side, Australian Meteorological Organization has a great site for keeping track of El Nino and ENSO. But I mean, I just go straight to wherever I find data. I wish I can, if you want to send me an email, I can copy and paste the links back for the data. Let's see what else. What's the most important skill we can teach our children to handle the future civilization? Will there be a future civilization? The question is, what should you tell your children? I have grandchildren. My grandchildren are 5, 8, 14, and 17. And the 8-year-old already knows. He has a good sense of it, but he doesn't really realize what the implications are. The 5-year-old, of course, no clue. The 14-year-old, well, she's a teenager, so she's just enjoying being a teenager. What can you tell your children? Just let them be kids. Let them find out on their own. Let them have their childhood. There's no reason to rush them into this awareness. There's no reason to, force this reality on them. Just try and live a good life, and model what you think is the best behavior you can for how to be on the planet right now. I can't speak for you, but for myself, that behavior just means doing as much service as I can, right? It means trying to save what I can, to work every day as a volunteer when I have the opportunities. Our local wildlife care network just sent out an email. They are looking for volunteers. They had an influx of juvenile songbirds, and they don't have enough volunteers. The songbirds need to be fed and have their cages cleaned roughly every hour. And so, if you have 40 cages with juvenile songbirds, it is a tough job. And I did that for a while last summer. So, find things that are on the ground, tangible ways to make a difference and model that behavior for your kids. That's the best, overall advice. All right, Climate Alert says insect apocalypse, nothing hits the windshield anymore. I've absolutely witnessed that here locally. I went on a bee hunt and I made a little video of it. I actually posted it to my Twitter a couple weeks ago. So yeah, we are definitely in the midst of an insect decline. And this has been noted and published, this decline. I think it's local. I put out sort of this tweet about it, and what I found out is that many people around the world were experiencing the same thing as I was. But then there were a few people who were like, no, you're totally wrong. There's way too many insects here. And if you are paying attention in the news recently, I think there's been this cricket infestation somewhere in Nevada where, there's so many crickets crossing the road that, they're making the road slick because of cars driving over them. So we're kind of having both sides of this go. It is a true apocalyptic situation with insects right now. Right. Where do I get the temps from? Somebody asks. Well, let me just show you where I get the temps from, because that is a good question. So if we go to Climate Reanalyzer, so hang on a second, I have to open up my browser and kind of switch over to all of that. So let me just see if I can't figure out how to do that for a second. So here we go. Let me just try and see if this works. So here we are on climatereanalyzer.com. And if we go to, for example, daily sea surface temperature time series and maps, and we get this right here. And then we can click on world and go to North Atlantic. And then we can go to export chart right here, and we can click down to download JSON data. And here it is. Here is all the data you ever wanted for North Atlantic sea surface temperatures. We have information. Well, the first full year's data is 1982 that you see here. And we have all the data all the way through today. And so here is today's value right here, 22.89 that I showed you before. And all these nulls right here are just placeholders for the rest of the year. Then you can get the mean data right here and the 2 sigma data right here. So this is an example of where I get data from, is Climate Reanalyzer. Another place that I get data from is directly from JAXA. So let me just hang on a second. I'll pull this up in just a second. So I actually I just get my daily North and South Antarctic sea ice extent directly from JAXA and import that into, whatever Excel spreadsheet I'm using. I mean, I just have all these data sources. So, but I do want the pure raw data. So that's it's an excellent question. Where do I get my data? Many, many places. Yes, Bella, I know I was on PBS NewsHour. It's pretty cool. Do I prefer the nickname Dr. Doomsday or Dr. Apocalypse? I like Dr. Jacobson. So no nickname there, please. Either one of those. Let's see what else. Kimberly Collison says, it won't happen, but people should stop having kids. Why set them up for the hardships ahead? I agree. But human biological, human nature, human desires override that sort of sensibility. And yeah, it's absolutely something that I agree with. How do I debate somebody who uses a graph of temperature change in the last few million years as proof of climate change has always been with us? I don't debate them. I just block them immediately. But I mean, that's a good question. So what would my answer be? It is not the fact that the climate has changed that's the problem right now. It is the rate of change. And when you talk about past changes in temperature, even the fastest changes that have happened have typically taken place over periods of thousands to tens of thousands of years that have given species, an opportunity to adapt through multiple life cycles, that have given species a possibility to migrate because, a lot of things just can't move very fast. So that's sort of been the typical. And then we have had some very sudden events over the years where climate has changed very fast, but usually that's local or regional. So you might have a very cold 100 or 200 years in Europe, for example, where people suffered and died and population collapsed, or you could have had a huge drought happen in Arizona, where indigenous peoples, their civilizations collapsed. I mean, these sorts of regional climate collapses have happened over and over again over the the hundreds of thousands of years, the last 20,000 years of human, sort of modern human civilization. But really, there has been nothing in the ballpark to what's happening now when it comes to the rate of change. The actual rate of change of our climate is what's new now. This rate of change is unprecedented in human history. Arguably the only time the climate ever changed this fast in the history of life on this planet has been when we got hit by the asteroid 66 million years ago. So, I mean, that is the basic argument. And let's see. What question do we have next here? So yeah, Bernard says you should just ask them how long humans have been on the planet. Yeah, I mean that's the point. Yes, the things changed very slowly millions of years ago, and it used to be that we had CO2 levels of 2,000 parts per million, and the entire planet was 10 degrees C hotter. Great. Humans weren't around then. Modern civilization wasn't around then. This civilization evolved during a very stable climate period, and we've just absolutely thrown it into chaos. So let's see what's next here. Thank you, Charles Whirl, for that comment. B.A. Charles says the crickets you grew up with went extinct. I love this comment by Adam McPherson. I just have to read this. I love this comment. A Doomer blogger, rice farmer, once wrote, "Jobs of the future will include farming, blacksmithing, farming, woodworking, farming, hunting, farming, and highway robbery." And did I mention farming? Adam, there's a problem with that. The problem is that we won't know what crops to plant. There is a good chance, not that the climate will move to some new steady state where you could say, now where I'm living, the climate is X, Y, or Z, and I can plant this or that the climate will actually move into a chaotic state where essentially we have the butterfly effect determining what you're going to experience any given year, whether it is going to be massive heat waves, droughts, storms that wash away all your topsoil, a cold part of the ocean that, suppresses sunshine because of all the fog that's there, like we're experiencing here in California this year. The problem is that you can't farm in climate chaos. And that there is a good chance, there are possibilities that we stop fossil fuels and things don't go into sheer chaos. But that's a possibility. The probability is that the future of the climate will be chaos. And that is, it's already happening. Wheat crops are failing, rice crops are failing. Why? Because the climate didn't act in a predictable fashion for that crop where it was planted for the given year. Going South says sea ice volume data is incoming as we chat. I have done some sea ice volume stuff too, and it is certainly well worth looking at. I have a link to that. I'm not going to show you that page, but it is certainly something I pay attention to as well. Okay, let's see. Will you just hang out there for a minute while I just have a drink? Talk amongst yourselves. I just need to take a 50. I've been on for 50 some minutes. I need a 1 minute. Okay, well, that didn't take too long, did it? Hopefully I didn't lose my entire audience. I just got this great question. It said, methane, is it growing linearly or is it started to grow exponentially? What's my best source for methane? I track methane here. And if you actually go to, oh, that wasn't good. Here it is. And what I do is I scroll all the way down to the bottom and I go to this particular link, and there, look at this, methane data, just the kind of stuff Elliot loves to play with. In our most recent methane reading, clear at the bottom here, let's see if I can make that visible to you. I guess not. Can you see that yet? No, not really. At any rate, you can just look at this methane data. And the question is, how is methane growing? And I mean, it's a complicated question, and one that I've really sort of paid a lot of attention to. And I tend to post something about methane when there is a story there to tell. So what happened with methane? We had during the last few years, we had all this, because of La Nina, all of this wetlands, we had tropical wetland growth because of excess water falling in that area of the planet. But then we have these wildfires, and the wildfires, tropical wildfires in Brazil and whatnot, they're spewing a lot of carbon monoxide. And it turns out that carbon monoxide cannibalizes hydroxyl, which is the main chemical that reacts with methane to sort of scrub it out of the atmosphere. So we have all of these reasons that methane, that's just one of them, all of these reasons that methane's half-life appears to be increasing. And so I was very curious about that last year, but almost a year ago, when we were setting record after record after record, not of the level of methane, but of the rate of methane accumulating in the atmosphere. And you have to be very careful when you do this calculation, because methane, the expected lifetime for a methane molecule is about 110 months on average, right? But if you happen to be a methane molecule that is sort of in the equatorial region, then there's a good chance you'll get hit by a hydroxyl and you won't last as long. But if there are fires scrubbing the hydroxyls, then you might last longer. So, methane doesn't have an actual half-life per se. It's sort of very dependent on the specific atmospheric conditions where that methane molecule lives. And so I was looking, I've been creating these charts that say, assume we have a 110-month lifetime for half-life for methane. Can we actually track in real time the amount of methane going into the atmosphere? And I put up those graphs on Twitter sort of every month. We went something like 31, 32 months consecutively with putting in more methane into the atmosphere every single month. And over the last 6 months, it turns out that has actually turned. And we are now, actually the planet is we're putting slightly less methane into the atmosphere. It's still record levels, right? It is still all-time record levels. The levels today are about the same as a year ago. But they went up this loop and came down again. So we are not putting as much methane in as we did. And when I say put as much methane in, I'm also talking about the cumulative scrubbing effect from hydroxyl taking it out. It's slightly less, right? So so if you like, the first derivative is positive, but the second derivative is now negative. And so that really tells you it's linear, but not exponential in any way. Let's see, have I recalculated my timeline to the end with this new data? No, I don't really like to talk about the end in any real sense. If you go to the Climate Casino on my website, I have an over-under, I believe, of 6 billion people. I'm not sure I actually made this wager, but that sort of, I'm on the record as saying 6 billion people is my over-under in the year 2050, all right? So 8 billion is the over-under for the year 2025. And so from a gambling perspective, I am looking at a huge crush, right? A bottleneck for human population happening in the next 25 to 30 years. And that bottleneck, if it kills a couple billion people, is going to be, mind-blowing that happens. I'm not really willing to go after that. So Miguel Delgadillo asks, what model do I choose if I want to do a forecast for sea level rise for 2024? Linear, quadratic, cubic exponential, or delta Dirac? By the way, delta Dirac, just so you know, is a function which is constant at zero, except at zero, it's infinite. So if you like, it's a flat, but at one singular point, it's infinite. And this function is used all the time. Is it infinite or is it height 1? I'm forgetting right now. one or the other. I think it might be height 1. So it's like a 0-1 function. And yeah, so in other words, are we going to have a climate collapse, a collapse of the Thwaites Glacier, for example, suddenly, or some Greenland ice collapse, or one of these new things that's happening, sort of an underwater tsunami in Antarctica, sort of generating some impacts afterwards. I don't know. I don't actually see. To me personally, sea level rise is like this. It used to be that sea level rise was all people talked about when they were talking about climate change. It's like it's all sea level rise all the time. Florida's in the East Coast and Bangladesh and Pakistan. Right? It was all sea level rise. But the problem is that all of these other things are going to happen before sea level rise, right? I mean, these wet bulb temperatures and these failures of crops and these, the entire list of things. There's an entire list that's going to happen before the impacts of sea level rise really hit home, unless there's a catastrophe. And if that catastrophe happens, it'll win. And I just don't know. I honestly don't know whether that will or won't be the one that makes the difference. Thank you for all your great questions. And I see I'm way behind on your questions, so let me just sort of sorry. Diego asks, Elliot, since it's Ask Anything, what are your thoughts on AI? What about UFOs? You should go to my YouTube channel and listen to the conversations I've had with my nephew, Ruben, who is quite concerned about artificial intelligence. I am naive enough that I just think there's so many other things going on right now that AI is not going to be the tipping point. I could be wrong. So I am going to just profess ignorance to that question. And what do I think about UFOs? Yeah, no way. There's no UFOs. Nope. And I mean, there's so many thousands of good reasons there's no UFOs. And there's no good reason that there are. So that's how I feel. So no UFOs. I'm not familiar with the work of Russ Finch. Boy, I really look bad, don't I, right now? Oh, Going South is just, yeah, you can get the volume data. Let's see, what else is going on? Sorry, I'm just reading through comments right now. Somebody asked, thanks, urgently seeking real-life examples of sustainable living. Our consumption habits led us here. Is there any individuals, groups, cities, or countries demonstrating non-destructive alternatives? I'm going to leave that into, hopefully somebody answered you in the chat. I am a human living on the planet Earth in the year 2023. I cannot live in a vacuum. I use technology. I use, plastics. I use a car. I have a house that is heated by gas. I cook by gas. The clothes I wear are not sustainable, though I try and avoid certain types of clothing. I mean, on and on and on. I mean, what's going to happen to this microphone 100,000 years from now? I mean, pretty much everything in our lives, if you want to exist in this world, is not part of this non-sustainable paradigm that we've created. And it's very sad, but I don't know. Let's see. Are we coming to an end? Is that it? You've asked all your questions. I'm looking for the questions here. Okay, what are my views on the impact for sea life given the rapidly evolving changes in SSTs? That's a really good question, Philip Coles. When I posted that graph about Atlantic sea surface temperatures, the very first contact I had from any sort of international media, of all things, was from Fishing Today magazine, right? And what they told me is, they said, could you please write an article about what sea surface temperatures are going to mean for fish? And most of the people who are commercial fishermen, they don't know about this, and they need to know. We need to know how this is going to impact our industry, and we would love to have you talk to us about that. And I decline that because honestly, I don't know anything about commercial fishing. However, there is this thing called deoxygenation, right? That is happening as waters heat up. They contain or are able to hold less gases. Oxygen is a gas. Fish have incredibly sophisticated mechanisms for pulling a microscopic amount of oxygen that is dissolved in water out of that water to allow them to breathe. And it does not take much in order to cause a die-off, which happened off the Texas coast, right, just recently. In fact, there is apparently a large die-off happening right now off the, is it the Mexican coast or that region? Because what's happened is a lot of birds are dying, right? There's a huge die-off of birds taking place along the, and I wish I knew the region. I'm just going to say the coast of the west coast of Mexico, but fill that in by filling in the blank from Google, and you'll find this article. And these fish, they thought they all had the avian flu. They thought they were dying from the avian flu, and they tested them, and no, they're all dying of starvation. These ocean, these fish, these birds that get their food from the ocean are dying of starvation. Why? Because there's no fish for them to eat. And in fact, we had this big issue with pelicans here in last year, summer of 22. And I was involved in rescuing the pelicans, and they thought, what is happening to our pelicans? They were just, they were weak and disoriented, and they were on our beaches. You just go up to them and pick them up. And we rescued hundreds and hundreds of pelicans. And it turns out they were just hungry. There were no fish for them, right? And actually, it was a little bit more complicated than that. It turned out that because of the warm water, there was an algae growth. And this algae had made it very difficult for these birds to see down through the water to be able to see where the fish were. And so they were actually starving because visually they couldn't identify the targets to dive at. And this year, apparently, the same starvation mechanism is happening, but it's from pure lack of fish. And I'm very glad that I haven't seen this impacting our local pelican populations yet. Let's see. Who do I like in the 2024 presidential race? I don't care. So I actively turn off all politics. So if I happen to be on a web page with politics front and center, if I hear it on the radio, if I see it on TV, I turn it off. It doesn't mean I don't have my personal opinions. I know who I'm going to vote for, and the person I'm going to vote for, whoever that ends up being, I know has not been indicted federally for any crimes. However, I already know that. I don't need to see any other politics. I don't want any part of politics. Politics are small. They are this big, right? I mean, what's going on planet-wide is beyond the scope of what I can show you, here. And politics is this big a part of it. It just doesn't matter. A Green Party, a Democrat, a Republican, a socialist government, do away with capitalism. It just doesn't matter anymore. None of that matters. We are already in a predicament. The predicament is here today, and no transformation of the globe to some political system where suddenly everyone is aware and changes their lifestyle instantly, and we somehow magically, some magic bullet solves everything. That's not happening, right? The opposite is happening. Chaos and war and threats of more chaos and more war, and we're going to have climate immigration that's going to cause border battles, right? And all of this stuff is just getting started. So in view of that, Day-to-day political decisions, yes, I care about certain issues. I care about a woman's right to choose her own health care, right? I have my opinions about issues. But that doesn't mean that one given political candidate or another is going to do anything to stave off the coming collapse. So, yeah, let's see. All right, where are we? Do you happen to know Guy McPherson? What are your thoughts on him? Yes, I know Guy McPherson. That's all you're going to get. Let's see. Is anyone? So Greg Walnick asks, does anybody create an algorithm capable of calculating in real time the balance between incoming energy from the sun and outgoing energy from the earth? I mean, that's a great question. I look at the earth energy imbalance, and typically the data I get has been reanalyzed and put through some processing that takes about 3 months. So the data that I am typically using or presenting or doing my data analysis with is not only is it not today's data, it's not this month's data, it's not last month's data, right? In early June, I put up March's data. So that's kind of the timeline that I'm aware of. I'm sure that there is some satellites that are capable of that kind of thing. I just don't know anything about that. So last questions. Do we have any last questions? And then I will just close this up. Let me just see if I am scanning through this. I mean, there's some great questions I didn't answer, and I apologize for not answering every question that was asked. I've said I don't know an awful lot today, and so sometimes it's just easier for me to skip a question than say I don't know. And let's see. Okay, so I guess that will do it for today. And I want to thank everybody, absolutely everybody who asked fantastic questions for joining me today here in this rather spontaneous moment on the YouTubes as a live, show. And it's been a month since I did this, and a month feels like about the right time. But if something comes up, another one of these dramatic things comes up, then I'll do it earlier than that. I'm going to try and do one a month. I like to do these things a little bit spontaneously. There's actually a reason for that. I do it spontaneously because, I mean, you don't know this, but I get trolled on Twitter, right? Trolled to the in the hundreds and thousands sometimes. And I am kind of proud of the fact of how good I am at blocking these people. And, I feel, though, that if I were to announce one of these a day or two in advance, that would make it into the subreddits, and that would make the rounds of all of the bulletin boards and so on, and it might even make it into the industrial weapons grade trolling farms out there. And then we couldn't have these conversations because my chat would be filled with trolls and they would just dominate everything. And I don't want to do this with moderators. So anytime that I want to do this, it'll probably be on short notice like this. Also, let me just mention, if you want to contact me for any reason, I put my email address on my website, climatecasino.net. You're welcome to email me. I really don't like to do anonymous. So I always ask that if you're going to contact me, that you don't use a pseudonym, that you just are polite enough that we could have a conversation that's you and me. And, contact me and let's see what happens. So, okay, everybody, that is going to do it for today. So, yeah, I will see you all next time. Bye, Doomers.